The Michaelis-Menten reaction mechanism. So this mechanism is composed of two elementary reactions. In the first one we have S combining with the free form of enzyme forming an enzyme substrate complex. In the second elementary reaction we have then that enzyme substrate complex decomposing into product and the free enzyme form again. There are three kinetic rate constants, K1 and K2 for the first elementary reaction and K3 for the second, which is irreversible. Now let's look at an example with the following parameter values, the rate constants here on the left, initial concentrations on the right, and just note that the substrate concentration is about 1,000 times larger than the enzyme concentration. Now if we observe a time course of this reaction, starting with the initial conditions we've just shown, we see product concentration increasing along time, more or less linearly, with a reciprocal decrease of the substrate concentration in red. And then after a while, at about 15 to 20 seconds, the reaction stops and all the substrate is converted to product. Now if we look at the forms of the enzyme, the free form here in blue and the enzyme substrate complex in green, there is a very sharp decrease of the amount of free enzyme, which is of course transformed into enzyme substrate complex right at the beginning. Then there is a much slower decrease of the enzyme substrate complex, and of course with the reciprocal increase of the enzyme concentration, free enzyme. If we look at the time course in terms of reaction rates, here reaction 1, binding of substrate in red, and reaction 2, the formation of product in blue, we see that a very sharp increase and decrease right at the beginning, and then the two rates meet more or less at around the value of 1, just slightly below that, and they will then overlap throughout the rest of the reaction period. If we look at an inset, here we see the very sharp increase of the reaction rate of reaction 2 and the decrease of reaction 1, and then they both overlap. In that period, both reaction rates are the same or very similar, which means the enzyme substrate complex concentration is changing very slowly or almost nothing. So that's a quasi-steady state. Now, we're no longer looking at the time course, but we're now looking at the profile of the initial rate versus the initial concentration of S. That is the rate of reaction right at the beginning, and that as a function of the initial concentration of substrate. So as we increase the initial substrate of the substrate, the initial reaction rate keeps increasing as well, and this is the famous rectangular hyperbola of the Michaelis-Menten mechanism. There is a maximal rate shown here, which the rate of reaction increases towards that as we increase substrate, but it never really reaches it. If we look at half of that reaction rate and we observe what is the concentration of the substrate that gives that rate, that's actually the value that we will later on call the Michaelis constant, Km. Now, if we look at the profile of the initial rate of reaction versus the total amount of enzyme or the initial amount of free enzyme, we now see that this is actually a linear dependency. So more enzyme creates a proportional increase in the initial rate. And this was the Michaelis-Menten kinetic mechanism.